Okay, today's lesson, this lesson here is on something called implicit differentiation. The type of differentiation that you've done so far in this course is really referred to as explicit. All right, there. Explicit differentiation, because the y has been all by itself on one side of your equation, and the x is usually written in some kind of an expression on the other side of your equation. So, what does it mean if a function is defined implicitly? Well, here's a really good example right here. Look at that equation right there. You have x's and y's, yes, but the x's and the y's are all mixed together. The y's are to the power of 5 or some other power. The x's and the y's sometimes are multiplied together, like right there. How in the world do we take the derivative of that? Well, that's where implicit differentiation comes in. If it's impossible to get your y by itself, then you have to take the derivative implicitly, because this is called an implicit function, as you can see right there. So how do we do that? What are the rules that we have to use to take the derivative of a function implicitly? Well, the rules really are the same as the rules you've already learned. You've got your power rule, you've got your product rule, your quotient rule, your chain rule. Any of those rules that you've seen before, you're going to use now. You take the derivative of the x's the way you always did. You take the derivative of the y's in a similar fashion. For example, you see right there you have a y to the power of 5. Well, the derivative of that would be 5y to the power of 4. But there's one other step that you have to take whenever you're taking the derivative of a y term. You have to multiply your derivative. Here, for example, 5y to the 4. You multiply that by y prime, the derivative, because that's really what you're doing. You're taking the derivative of the whole function itself. Y is what the name of the function is. So that's really the only difference, and that's what you have to remember, is that you always, if you're taking the derivative of a y, you write y prime beside it. It has to be multiplied by y prime. So let's dive right in. Let's try some of these examples that's on page 43 in your textbook. The first one is, I'm not even going to bother with that one. The first one is really easy. You can look at that one if you like and give it a try. But what I'm going to do is dive right in and try the second example right here. All right, that's the one I'm going to try next. I'm going to try that one. And you can see the x's and the y's are all kind of mixed up together. They're on one side. You wouldn't be able to get that y by itself. That's not even really a function. Some of you might recognize that equation. It's got an x squared and a y squared. They're added together. The numbers in front are different. That, ladies and gentlemen, is an ellipse. That's an ellipse. That's what we were doing back in chapter number 3, I believe it was, conic sections. So let's take the derivative of y squared plus 2x squared equals 5. And the first term you have is y squared. Well, the derivative of y squared is 2y. So you write your 2y. But remember, you just took the derivative of a y term, so that must get multiplied by y prime. You do that every time you take the derivative of a y. And then we've got a plus sign, so I write plus. And the next term we have is 2x squared. Well, we have to take the derivative of that piece as well. And so that's going to become just 4x. Now, I don't write y prime beside that because I didn't take the derivative of a y. I took the derivative of an x term. And then I write equals. And on the right-hand side, we've got a 5. You even take the derivative of that. That's a constant. And we saw the very first rule we saw when taking derivatives is that the derivative of a constant is always 0. So we write in 0 there. So, question now becomes, is that our derivative? Well, kind of, but we haven't written it in the correct form. We've got to get the y prime by itself now. So here's your y prime right there. It's only in the equation once. You somehow have to remove this plus 4x, and you have to remove this 2y that's in front of it. and get the y prime by itself. So it's just like it's solving an equation for y prime. Take your 4x to the other side first. So let me just come over here. You would have 2y prime is equal to negative 4x. That's what you have so far. And now to get the y prime by itself, you would divide both sides by 2y, like so. The 2's cancel, the y's cancel, so all you have left is your y prime, your derivative. You could even write the dy over dx instead of y prime, but that's entirely up to yourself. Some people would rather write dy dx because that's also the derivative of y with respect to x. And I noticed that over here now in my solution, it can simplify a little bit. I have 4 on the top, 2 on the bottom. They're factors, so they can reduce. So your final reduced answer is negative 2x over y. And for the first time, you now see a derivative that's got both x's and y's in it, right there. And I told you that was coming. I said to you that you're going to be seeing derivatives that contain x's and y's. Now what this means is that if you had to get the slope of that curve, that original ellipse, if you had to get the slope at some point, you'd need both the x and the y coordinate of that point to plug in to your derivative to get the slope of the function. Okay, so if you're only given the x value, you'd have to plug that back into the original function to get your y value. You do need both of them for a case like that. So there's your answer for the first one, implicit differentiation. The example that comes right after that, well, let's give that one a try as well. All right, so I'll just wait for everyone to get this part copied down. If you're copying it down, all these full solutions, remember, they've been all posted on D2L. All right, so I'll delete that. Remember, you can come back and look at this anytime you like. These are all saved in D2L. All right, so here's the next one. It says find dy dx. That means your derivative. Now you can also use y prime if you like. You don't need to use dy dx. Some people like dy dx. And let's see what we have here. We have 3y to the power of 4. Okay, we know what to do there. We then have, be careful. Look at this thing. Look at that. That is actually a multiplication. X is multiplied by y squared. You are going to require your product rule there. And you saw your product rule in yesterday's class. So when you use your product rule, make sure that you put the two terms, whatever the two pieces are, in brackets. And the reason that you need the brackets, or you should use the brackets, is that sign right in front of it. You see that? Now here you don't have to worry because it's a plus sign. But if that was a minus sign, then the minus in front of a set of brackets really matters because then the signs of everything inside would change. So make sure, please, that if you're going to have to use your product rule here, that you do use some brackets. Okay, so let's go ahead. Let's start doing this one. The first thing we have, that term right there, 3y to the power of 4. Well, the derivative of that, 3 by 4, is 12y cubed. There's your first piece. But we took the derivative of y. So beside it, I must write y prime. Now remember, that's not y to the power of 1. That's y prime. That's your derivative. That's your dy by dx. Plus. And now the second piece, product rule. So let's put some brackets. We'll put our answer here in brackets. And let's do it piece by piece very carefully. The product rule says take the derivative of the first piece. Well, that's just x. So the derivative of that first piece is 1. Multiplied by. And the second piece you leave as is. So that's just y squared. So you just write y squared beside that. 1 multiplied by y squared. Not y squared y prime because you didn't take the derivative of the y. Now, plus. The second thing you do for your product rule is you break down the first term, which in this case is just x. And that gets multiplied by the derivative of y squared, which is 2y. And now because you took the derivative of y, you also put a y prime beside that. And then what else do we have? Well, we've got plus 2x cubed, so the derivative of that would be plus 6x squared. And now minus 6, well, the derivative of that's just 0 because that's a constant. And equals, and the derivative of 0 on the other side is also 0. So there's what we've got so far. Now we've got to clean that up, and we've got to get the y prime by itself. So let me see, I'm kind of running out of room here. Let me come down here. 12y cubed y prime plus y prime plus, now 1 times y squared is just y squared. Now if that was a negative in front, if that was a minus, remember that would go through your brackets, but it doesn't here. Plus x times 2y is 2xy, and now we get y prime beside that, plus 6x squared is equal to 0. Now, notice that you've got y prime here in 2 locations, not just one. It's there twice. It's there and it's there. Now, if this was a simple linear equation and you had the x's there twice, you know what you'd do. You'd get your x's together on one side, and you'd throw everything else to the other side. So that's what we're supposed to do here. So keep the 12y cubed y prime on this side, and plus 2xy y prime. Leave them both on this side. And now throw on the other side your negative 6x squared, and also the plus y squared throws over as well, so that's just minus y squared. And I'm running out of room. Let me come up here. Now, y prime on the left side is a common factor, so that comes out in front, just like if that was 2x's, you take it out in front. So 12 is y prime in front of, y prime in front of, where am I? Okay, 12 y cubed plus 2xy, closing bracket, equals, and now on the other side you had negative 6x squared minus y squared. That's what you have on the other side. And now to get the y prime by itself, all you do is divide both sides by this thing, 12y cubed, my goodness, this pencil is awful, plus 2xy. Divide this side, the right side, by it as well. Now these will cancel, and you've got your y prime by itself. Now where in the world am I going to write that to? Let me see. Can I come back here and erase some of this, I wonder? No, maybe I can't. But anyway, you're going to have negative 6x squared minus y squared over 12y cubed plus 2xy. 12y cubed plus 2xy. If anybody knows where I can get a half-decent stylus, a half-decent marker, let me know. Okay, so anyway, that's what it's supposed to look like. Now we're almost out of time. There is one more example on that page. I'm going to leave that one for you to try. Notice this one actually says find the slope of the line. Find the slope of that curve, right? The tangent line at that point. But they do give you the x and the y right there. So be careful when you're finding the derivative, though. Notice it's implicit, and by golly, look, that's got an x times y as well. So you're going to need to use your product rule. So I'll leave that with you to try. And there's also some more exercises after this. So I'll assign those to you as well now after the next lesson. But I'm going to start the last video now for today. And that was actually fairly simple, fairly straightforward. And so I'll see you in a few minutes.